Hello everyone and welcome back to our videos. Today we will talk about fuel system requirements and we will take most of the requirements, not all of them. We will start with number 1 FAR 23.951 and it identifies that each fuel system must be constructed and arranged to ensure fuel flow at rate and pressure established for proper engine and auxiliary power unit under all operating conditions. The second requirement: no pump can draw fuel from more than one tank at a time, and provisions must be made to prevent air from being drawn into the fuel supply line. Number 3. Turbine-powered aircraft must be capable of sustained operation when there is at least 0.75 centimeter cubic or cubic centimeter of water per gallon of fuel, and the fuel is cooled to its critical temperature. Number 4. Each fuel system of a multi-engine aircraft must be arranged in such a way that the failure of any one component will not cause more than one engine to lose power. Number 5. If multi-engine aircraft feed more than one engine from a single tank or assembly of interconnected tanks, each engine must have an independent tank outlet with a fuel shut-off valve at the tank. Number 8 requirements: tanks used in multi-engine fuel systems must have two vents arranged so that they are not likely to both become plugged at the same time. Number 8. All filler caps must be designed so that they are not likely to be installed in such a way that could cause an in-flight loss of fuel from siphoning. Number 10. The fuel systems must be designed to prevent the ignition of fuel vaporized by lightning. Number 11. A gravity feed system must be able to flow 150% of the takeoff fuel flow when the tank contains the minimum fuel allowable and when the airplane is positioned in the attitude that most critical for fuel flow. Number 12. A pump feed fuel system under the same conditions that are specified for a gravity feed system must be able to flow 125% of the fuel flow required for takeoff. Conditions are when the tank contains the minimum fuel allowable, when the airplane is positioned at the attitude that most critical for fuel flow. You have to take care. Here we talk about pump feed and the percentage is 125, but in the previous one we was talking about the gravity feed and it was 150. Number 13. If the aircraft is equipped with a selector valve that allows the engine to operate from more than one fuel tank, the system must not cause a loss of power for more than 10 seconds for a single engine or 20 seconds for a multi-engine airplane between the time one tank is allowed to run dry and the time at which the required power is supplied by the other tank. Number 14. Turbine-powered aircraft must have a fuel system that will supply 100% of the fuel required for its operation on all flight altitudes, and the fuel must not interrupted as the fuel system automatically cycles through all of the tanks or fuel cells in the system. Number 15. A gravity feed system has interconnected tanks outlets. It should not be possible for fuel feeding from one tank to flow into another tank and cause it to overflow. Provisions must be made to prevent overflow of fuel from one tank to another. Number 16. The amount of unusable fuel in an aircraft must be determined, and this must be made known to the pilot. Unusable fuel is the amount of fuel in a tank when the first evidence of malfunction occurs. The aircraft must be in the altitude that is most adverse for fuel flow. Number 17. The fuel system must be so designed that it is free from vapor lock when the fuel is at temperature of 110 Fahrenheit under the most critical operating conditions. Number 18. Each fuel tank compartment must be adequately vented and drained so no explosive vapors or liquid can accumulate. Number 19. No fuel tank can be on the engine side of the firewall, and it must be at least 1/2 inch away from the firewall. Number 20. Each fuel tank must have a 2% expansion space that cannot be filled with fuel. Each fuel tank must have a drainable sump where water and contaminants will normally accumulate when the aircraft is in its normal ground altitude. 22. Provisions must be made to prevent fuel spilled during filling the tank from entering the aircraft structure. 23. The filler opening of an aircraft fuel tank must be marked with the word fuel. For aircraft with reciprocating engines with the minimum grade of fuel. For turbine-powered aircraft, the tank must be marked with the permissible fuel designation. If the filler opening is for pressure fueling, the maximum permissible fueling and defueling pressure must be specified. 24. If more than one fuel tank interconnected outlets, the airspace above the fuel must also be interconnected. 25. If the carburetor of fuel injection system has a vapor elimination system that returns fuel to one of the tanks, the returned fuel must go to the tank that is required to be used first. 26. All fuel tanks are required to have a strainer at the fuel tank outlet or at the booster pump. For reciprocating engine, the strainer should have an 8 to 16 mesh element, 8 to 16 mesh screen. For turbine engine, the strainer should prevent passage of any object that could restrict the flow or damage any of the fuel system components. 27. 27. For engines requiring fuel pumps, there must be one engine-driven fuel pump for each engine. 28. There must be at least one drain that will allow safe drainage of the entire fuel system when the airplane is in its normal ground attitude. 29. If the design landing weight of the aircraft is less than that permitted for takeoff, there must be provisions in the fuel system for jettisoning fuel to bring the maximum weight down to the design landing weight. Number 30. The fuel jettisoning valve must be designed to allow personnel to close the valve during any part of the jettisoning operation.